In question 1, we've got the curve C with these parametric equations, and we need to show that all points of the curve C lie on the Cartesian equation y is ax minus 1 over bx, where a and b are constants to be found. Well, starting with the two Cartesian equations, the objective is to combine and remove the t, so we end up with something connecting x and y. So we've got x is t over t minus 3, so I will cross multiply to get x t minus 3x is equal to t, leading to x t minus t is equal to 3x, and therefore t brackets x minus 1 is equal to 3x, which means that t is equal to 3x over x minus 1. Now for y being equal to 1 over t plus 2, I will start by moving the 2 on the left hand side, so we've got y minus 2 is equal to 1 over t, and if I take the reciprocal of both sides, we end up with 1 over y minus 2 being equal to t, and I can now equate the two expressions for t, leading to 3x over x minus 1 being equal to 1 over y minus 2. I will cross multiply to get 3x times y minus 2 is equal to x minus 1. We will expand the left hand side to get 3xy minus 6x is equal to x minus 1, leading to 3xy is equal to 7x minus 1, and therefore y is equal to 7x minus 1 over 3x. In 2a, we are asked to express 3x over 2x minus 1 times x minus 2 in partial fraction form. So we'll start by decomposing the expression we were just given. So we've got 3x over 2x minus 1 times x minus 2, which I will express as a constant a over 2x minus 1 plus another constant, say b, over x minus 2. Now I want to get rid of the denominators, and I'll be multiplying throughout by the LCM, which is 2x minus 1, x minus 2, leading to 3x is equal to a brackets x minus 2 plus b brackets 2x minus 1. Now what we're dealing with here is an identity, which means that it holds true for every value of x. So we can see that if we set x minus 2 to be 0, so if we set x to be 2, then these will vanish and we'll be able to recover the value of b. So let's set x to be 2, leading to 3 times 2 is equal to b times 2 times 2 minus 1. So we're dealing with 6 being equal to 3b, and therefore b is equal to 2. Now another nice value of x will be the value of x that will make 2x minus 1 0. So obviously we're looking at x being a half. So if we put x to be a half, this leads to 3 times a half being equal to a times a half minus 2. So we've got 3 over 2 is equal to minus 3 over 2 times a, and therefore a is equal to negative 1. And all we are missing is to write our final answer, so write the decomposition into partial fraction form as 3x over 2x minus 1 x minus 2 being equal to minus 1 over 2x minus 1 plus 2 over x minus 2. In part B, we are asked to hence show that the integral from 5 up to 25 of the expression we just decomposed into partial fractions gives an answer of ln k, where k is a fully simplified fraction to be found. Well, let's start. We are looking at the integral from 5 up to 25 of negative 1 over 2x minus 1 plus 2 over x minus 2. We know that both of these will give me a length as the answer. So we're looking at minus a half ln of 2x minus 1. Well, the integral of 1 over 2x minus 1 is ln of 2x minus 1, and I divide by the derivative of the inside. So I divide by 2 plus 2 ln of x minus 2, and the limits are 5 and 25 respectively. I will proceed by substituting the upper limit. So we're looking at minus a half ln of 2 times 25 minus 1 plus 2 ln of 25 minus 2, and then I will substitute the lower limit, so minus the negative a half ln of 2 times 5 minus 1 plus 2 ln of 5 minus 2, and I will proceed by simplifying. It's minus a half ln of 49 plus 2 ln of 23 plus a half ln of 9 minus 2 ln 3. Now we know that the minus a half can come up as a power, so we're looking at a ln of 49 to the minus a half plus a ln of 23 squared plus a ln of 9 to the a half minus a ln of 3 squared, which gives a ln of 1 over 7 plus a ln of 529 plus ln 3 minus ln 9. We know that the addition of logarithms leads to the logarithm of the product, whereas the deduction will lead to a division. So we're looking at a ln of 1 over 7 times 529 times 3, all of it divided by 9. If you plug this on the calculator, you get a ln of 529 over 21, which is our final answer. In question 3, we are given the vectors PQ and PR, and we are asked to find the vector RQ. Well, we know that to go from R to Q, I can go from R to P and then from P to Q. Now we don't have the vector RP, but we do have the vector PR. So the vector RP will simply be the negative of this. So it's going to be negative 8, 5, negative 3. And we've got the vector PQ, it's 2, negative 3, 4. So if I add the I components, I get negative 6. The J components give me a 2, and the K components give me a 1. So the vector RQ is negative 6, 2, 1. In part B, we're asked to find the size of the angle PQR in degrees to 3 significant figures. So looking at the triangle here, we're trying to find the size of the angle Q here. So standing at Q, I will be considering the vector QR and QP, and I will be doing their dot product. Well, we know that QR dot QP should be equal to the magnitude of QR times the magnitude of QP times the cosine of the angle we're trying to find. Now the vector QR is simply going to be the negative of the vector RQ we just found in part A. So we're looking at 6, negative 2, negative 1. The vector QP will be the opposite of PQ, so it's going to be negative 2, 3, negative 4. And this should be equal to 6 squared plus negative 2 squared plus negative 1 squared, which is the magnitude of QR, times negative 2 squared plus 3 squared plus negative 4 squared square rooted, which is the magnitude of QP, times cos theta. Well, we know that when we're doing the dot product, we do I with I, then J with J, and then K with K, and we add everything up. So 6 times negative 2 is negative 12. Negative 2 times 3 is negative 6, and negative 1 times negative 4 is 4. And this is equal to root 41 times root 29 times cos theta. So this leads to negative 14 being equal to root 41, root 29 cos theta. So negative 14 over root 41, root 29 is equal to cos theta. I'm going to do shift cos of the left-hand side, leading to theta being 113.954 ... and therefore to 3 significant figures, it's 114 degrees. In 4a, we're given g of x, and we need to find in ascending powers of x the first 4 non-zero terms of its binomial expansion, giving each coefficient in its simplest form. So we've got 1 over the square root of 4 minus x squared. The first thing to do is to write this as 4 minus x squared to the minus a half. The 4 will be factored out, leading to 4 to the minus a half times 1 minus x squared over 4 to the minus a half. Remember that whatever we factored out, we also divided by within the bracket. So we are trying to obtain an expression of the form 1 plus or minus something raised to the power of n in order to proceed with the binomial expansion. Now we know that 4 to the minus a half is simply 1 over 2, so we're looking at 1 over 2, and then for the binomial expansion, we've got 1 plus the power of minus a half times minus x squared over 4, plus the power of a minus a half, deduct 1 from the power, it's minus 3 over 2, divided by 2 factorial times minus x squared over 4 raised to the power of 2, and then we've got the minus a half. We deduct 1, it's minus 3 over 2. We deduct another, it's minus 5 over 2 over 3 factorial. And now we've got minus x squared over 4 to the power of 3. And then we simply need to start simplifying terms. So we've got a half brackets 1 plus x squared over 8 plus 3x to the power of 4 over 128 plus 5x to the power of 6 over 1024 plus ... I will further expand this to arrive at a half plus x squared over 16 plus 3x to the power of 4 over 256 plus 5x to the power of 6 over 2048 plus ... In part B, we're asked to state the range of values of x for which the expansion is valid. Well, we know that once we put our expression in the form of 1 plus or minus something, then the modulus of this something being less than 1 will give me the range of validity for the expansion. So in this case, the expansion is valid for the modulus of x squared over 4 being less than 1. This simply means that the modulus of x squared is less than 4, so we're simply looking at the modulus of x being less than 2. In part C, we need to use the expansion from part A to find a fully simplified rational approximation for root 3, showing the working and making the method clear. Well, let's recall that g of x is 1 over the root of 4 minus x squared. So we notice that g of 1 is equal to 1 over the square root of 4 minus 1 squared, which of course simplifies to 1 over root 3. This simply means that if we substitute x to be 1 into the expansion we obtained in part A here, we will be obtaining an approximation for 1 over root 3. So we're looking at 1 over root 3 being approximately equal to a half plus 1 squared over 16. So I'm substituting x with 1 here, plus 3 times 1 to the power of 4 over 256 plus 5 times 1 to the power of 6 over 2048, which gives an answer of 1181 over 2048. So this is an estimation for 1 over root 3. So if I take the reciprocal of both sides, I conclude that root 3 is approximately 2048 over 1181. Now, alternatively, someone could have proceeded from 1 over root 3, rationalize the denominator to arrive at root 3 over 3, which means what we have obtained here as 1181 over 2048 is also an approximation for root 3 over 3. So if I cross multiply, we get that 3 times 1181 over 2048 is approximately the root 3, which concludes that root 3 is approximately 3543 over 2048. Both of these answers are acceptable for full marks. In question 5, we're given a sketch of part of the curve with this equation. The region R is shown here, bounded on the left-hand side by 1 over root 2, on the right-hand side by k. It's rotated through a full revolution about the x-axis, and we are told that the volume of the solid generated is 713 over 648 pi, and we need to use algebraic integration to determine the exact value of the constant k. Well, we know that the volume of revolution is given by pi, the integral of y squared dx, with the limits being 1 over root 2 and k. Well, we know that this is pi times the integral of 1 over root 2 up to k. Y squared is simply this expression squared, so the 12 squared will give me 144. The root x squared will give me x, and then in the denominator I'm dealing with 2x squared plus 3 raised to the power of 3 dx. So I can write this as pi times the integral from 1 over root 2 up to k over 144x times 2x squared plus 3 to the minus 3 with respect to x. And bearing in mind that the integral of f dash of x times f of x dx is simply f of x to the n plus 1 over n plus 1 plus c. So this is called integration by recognition, or using standard patterns, or using the reverse chain rule. What I see here is that it would be great if we could see in front of the brackets the derivative of 2x squared plus 3, which is simply 4x. So what I will do, I will split the 144 as 36 times 4. So we're dealing with 36 pi, the integral from 1 over root 2 up to k of 4x times 2x squared plus 3 to the minus 3 dx. So now we've got exactly the derivative of the bracket here, so I can proceed. We're looking at 36 pi times 2x squared plus 3 to the minus 2. I'm increasing the power by 1, dividing by the new power from 1 over root 2 up to k, and I will then proceed by substituting the limits. Before I do that, I will do some simplifications. I'm looking at 36 pi over negative 2 times 2x squared plus 3 to the power of 2, with the limits being 1 over root 2 and k. Now obviously the 36 with the 2 simplified to leave me an 18 in the numerator. So if I substitute the k, I get minus 18 pi over 2k squared plus 3 raised to the power of 2. And if I substitute the 1 over root 2, I get minus 18 pi over 2 times 1 over root 2 squared plus 3 to the power of 2. So let's proceed. We've got minus 18 pi over 2k squared plus 3 raised to the power of 2 plus 9 pi over 8, and we have been told that the volume of revolution is 713 pi over 648. I notice that there is a common factor of pi throughout, so I will cancel this out, and this takes me to 2 over 81 being equal to 18 over 2k squared plus 3 squared. Remember, we're trying to find the value of the constant k. I will simplify the 2 with the 18, leaving me a 9 on the right hand side, and I will cross multiply to get 2k squared plus 3 raised to the power of 2 being equal to 729, which means that 2k squared plus 3 is the square root of 729, which is 27, leading to 2k squared is equal to 24, and therefore k squared is 12, which simply means that k is equal to root 12. In question 6, we are given a sketch of the curve C defined parametrically here in terms of t, with t taking values between minus pi over 6 and pi over 3 inclusive. We are told that we are crossing the x-axis at the point P, and we need to find the equation of the tangent to C at P in the form y cos mx plus c. Well, first of all, let's start by finding the value of t at P. We know that at P we've got y being equal to 0 because we're dealing with a cut on the x-axis. This simply means that 2 cos of 2t is equal to 0, so cos of 2t is 0. Now we know that the cosine of pi over 2 is 0, so that means that 2t is equal to pi over 2, and therefore t is equal to pi over 4. I will then proceed by finding dx dt and dy dt in order to find the gradient of the tangent. Now dx dt, I will be differentiating the 1 plus 3 tan t, which is the expression for x in terms of t. Well, the derivative of 1 is 0, and the derivative of tan t is sec squared t. So we're looking at dx dt being 3 sec squared t. And then for dy dt, I will be differentiating the 2 cos 2t, the expression for y in terms of t. Well, the derivative of cos is negative sine, and I need to multiply by the negative 2. So we've got 2 times negative 2 sine of 2t, which simplifies to minus 4 sine 2t. And therefore, we're looking at dy dx, which we know is equal to dy dt over dx dt. So in our case, it's going to be negative 4 sine of 2t over 3 sec squared t. and I will proceed in finding the x-coordinate, the value of dy dx, and proceed to find the equation of the tangent. Well, we know that t is pi over 4, so x is going to be 1 plus 3 times the tan of pi over 4, which gives an answer of 4. We have already established that y is 0 because it is a cut on the x-axis, and then dy dx would be equal to minus 4 sine of 2 pi over 4 over 3 sec squared of pi over 4. This gives an answer of minus 2 over 3. And using y minus y1 is mx minus x1, we're looking at y minus 0 is equal to minus 2 over 3 brackets x minus 4, which leads to y is minus 2 over 3x plus 8 over 3. We then have that the curve C has equation y is f of x, where f is a function with a domain from k up to 1 plus 3 root 3, and we need to find the exact value of the constant k. We're looking at the diagram provided. The 1 plus 3 root 3 is the end point for x on the right-hand side, and the k is the point on the left-hand side. So we can see from the diagram that k is negative. Well, let's recall that x is 1 plus 3 tan t, and t varies between minus pi over 6 and pi over 3. I will substitute t to be minus pi over 6 into the expression for x, so it's 1 plus 3 tan of minus pi over 6, which gives an answer of 1 minus negative 3, and therefore we conclude that k is 1 minus negative 3. In part C, we need to find the range of f, so this is the diagram. The range refers to the y values, so from the minimum up to the maximum. Well, it's easy for the minimum here. We know that t is pi over 3 at the minimum, and for the maximum here, we will be setting dy dx to be 0. Well, we know that dy dx is minus 4 sine 2t over 3 sec squared t. I will set this to be equal, so obviously we need to solve sine of 2t being equal to 0. If we recall the sine wave, we see that it is 0 every pi, so that means that 2t is equal to 0, pi, 2 pi, etc. So if I divide throughout by 2, I get that t is 0, pi over 2, pi, dot, dot, dot. Looking at the domain of values for t, I can see that the only solution out of the 3 here is the 0. So I need to evaluate y when t is 0. So I will simply say that when t is 0, we get that y is equal to 2 cos of 0, which gives an answer of 2. This is the y coordinate of the maximum here. And then I will substitute t is pi over 3 to find the minimum. So when t is pi over 3, y is equal to 2 cos of 2 pi over 3, which gives an answer of negative 1. So we can see that the range is from negative 1 up to 2 inclusive, and therefore we conclude that we've got minus 1 less than or equal to f of x less than or equal to 2. In 7i, we need to use the substitution u is e to the x minus 3 to show that the given integral gives an answer in the form of a plus b ln 2, where a and b are constants to be found. Well, let's start with the substitution we've been given. U is e to the x minus 3. The first thing to do is find an expression for the u in terms of dx, so I differentiate from left to right, leading to du being equal to e to the x dx. It also makes sense to change the limits. Remember, this is a translation process. Everything involving x, including the dx and the limits, need to be translated from x into u. So we've got, first of all, x being ln 5, which means that u is e to the ln 5 minus 3, which gives an answer of 2. And then for x being ln of 7, we're looking at u is e to the ln 7 minus 3, which gives an answer of 4. And therefore the integral from ln 5 up to ln 7 of 4e to the 3x over e to the x minus 3 dx will be written as the integral from ln 5 up to ln 7 of 4 e to the 2x over e to the x minus 3 times e to the x dx. So what I have done here, I have written e to the 3x as e to the 2x times e to the x, and then I will write the e to the 2x as e to the x raised to the power of 2. So we're looking at the integral from ln 5 up to ln 7 of 4 brackets e to the x squared over e to the x minus 3 times e to the x dx. So I'm now ready to proceed with the substitution, because we know that e to the x dx is simply the du term. Now in the place of e to the x, I will simply put a u plus 3, and in the place of e to the x minus 3, we're going to put a u, and we will also be substituting the new u limits. So it's the integral from 2 up to 4 of 4 u plus 3 squared times the u over u. So I will expand the u plus 3 squared. I will take the 4 out, so it's 4. The integral from 2 up to 4 of u squared plus 6u plus 9, and all of it divided by u du. And we're looking at 4. The integral from 2 up to 4 of u plus 6 plus 9 over u du. I can proceed with integrating. We are looking at 4. The integral of u is u squared over 2. The integral of 6 is 6u, and the integral of 9 over u is simply 9 ln u, and the limits are 2 and 4. So I will proceed in substituting the upper limit. So let me write the 4 outside, and we've got the 4 squared over 2 plus 6 times the 4 plus 9 ln of 4. That's the upper limit substituted, minus the lower limit, which is 2 squared over 2 plus 6 times 2 plus 9 ln 2. Let's close the brackets here, and let's proceed with simplifying. So we're looking at 4 times the 32 plus 9 ln of 2 squared. So I'm writing the 4 as 2 squared here, because at the back of my mind I'm trying to simplify things. And then the second bracket here will give me overall a negative 14 minus 9 ln 2. Now we know with the power law of logarithms that the 2 can come down. So 32 minus 14 is 18. So we're looking at 4 brackets 18 plus 18 ln 2 minus 9 ln 2. And therefore we've got 4 brackets 18 plus 9 ln 2, which I will expand to get 72 plus 36 ln of 2. In IAI, we need to show by integration that the integral of 3e to the x cos 2x is of this form, with p and q being constants to be found and c being an arbitrary constant. This is a classic case where we will be using integration by parts. So I will be choosing u to be 3e to the x and v dash to be cos of 2x. This means that u dash is 3e to the x, and v is the integral of cos 2x, which gives me a half sine of 2x. So the integral is uv, so 3e to the x times a half sine of 2x, minus the integral of u dash, which is 3e to the x, times the v, which is a half sine 2x dx. So at the moment we've got that the integral of 3e to the x cos of 2x dx is equal to 3 over 2e to the x sine 2x minus 3 over 2 times the integral of e to the x sine 2x dx. So I will be reapplying integration by parts on the integral of e to the x sine 2x. I will be setting u to be e to the x and v dash to be sine 2x. This means that u dash is equal to e to the x and v is minus a half cos of 2x, and therefore the whole integral of 3e to the x cos 2x dx is equal to the 3 over 2 e to the x sine 2x we had, minus 3 over 2, and I will open brackets here. We've got uv, which is minus a half e to the x cos 2x minus the integral of u dash v. Well, the minus here will make the minus here positive, so it's going to be plus a half e to the x cos of 2x dx, and we close the brackets here. So we're looking at the integral of 3 e to the x cos 2x dx being equal to 3 over 2 e to the x sine 2x plus 3 over 4 e to the x cos of 2x minus 3 over 2 times the integral of a half e to the x cos of 2x dx. I will rewrite the right hand side as 3 over 2 e to the x sine of 2x plus 3 over 4 e to the x cos of 2x, and I will rewrite the minus 3 over 2 times the integral here. I will take the 3 within the integral, I will take the 2 outside. So we're looking at minus a quarter times the integral of 3 e to the x cos 2x dx. This is an example of cyclic integration because after applying integration by parts twice, we still have an integral that we don't know how to deal with. However, we notice that if we call the original integral the integral of 3 e to the x cos 2x, if we call this I, then we've got exactly the same integral here on the right hand side. So this here is also I, and therefore we can proceed in saying that I is equal to 3 over 2 e to the x sine 2x plus 3 over 4 e to the x cos 2x minus a quarter I. Remember, we're trying to find I here. So if I collect the items on the left hand side, we've got 5 over 4 I is equal to 3 over 2 e to the x sine 2x plus 3 over 4 e to the x cos 2x. And if I divide throughout by 5 over 4, I get that the integral I is equal to 6 over 5 e to the x sine 2x plus 3 over 5 e to the x cos 2x, and I will put the constant of integration plus c. In question 8, we had a student who was asked to prove by contradiction that there are no positive integers x and y such that 3x squared plus 2xy minus y squared is 25. We've got the start of the proof here. The student started by factorizing the left-hand side into 3x minus y times x plus y. Now the idea here is that we're dealing with positive integers, so which two positive integers multiplied together can give me a result of 25? Well, obviously one case would be 1 times 25. The student has considered 3x minus y being 1 and x plus y being 25, leading to x being 6.5 and y being 18.5, which are not integers, and we are asked to complete the proof by showing the calculations and the statements needed. So I need to consider which other scenario could result into a final product of 25. So apart from 1 times 25, we could consider 25 times 1. So if 3x minus y is equal to 25 and x plus y is equal to 1, we've got simultaneous equations here in x and y, which I can solve by adding them up. This leads to 4x being equal to 26, and therefore x is 6.5. Now if x is 6.5, y is minus 5.5, both of which are not integers, I need to explicitly state this, and then I need to proceed in considering which other combinations of integers will give you a product of 25. Now the only such other case is the 5 times 5. So I will now consider if 3x minus y is equal to 5 and x plus y is equal to 5. Once more, we've got simultaneous equations in x and y. I will add them up, leading to 4x is equal to 10, making x being 2.5, and y is 2.5. So again, I don't have integers as my answers. I need to explicitly state this down. And therefore, we've got a contradiction because we wanted both x and y to be integers. This means we can conclude that there are no positive integers x and y such that 3x squared plus 2xy minus y squared is 25. Now, in case you were wondering why didn't we consider the scenario maybe of minus 5 times minus 5, which gives me a result of 25, well, the fact that we are only investigating positive integers x and y means that the two numbers here, the product here is the product of two positives, so no need to consider the negative times negative scenario to give me an answer of 25. In question 9, we're told that with respect to a fixed origin O, we've got the two lines L1 and L2 shown here, and we need to prove that the two lines are skew. Now, what does it mean for two lines in the 3D space to be skew? It means that they are not parallel and they do not intersect. So we cannot directly prove that two lines are skew. Instead, we will start by stating that if we look at the direction vectors of the two lines, they are not multiples of each other, and therefore the two lines are not parallel. So we rule out the possibility of them being parallel, and then I will investigate the possibility of them intersecting. So I'll be equating the I and then the J and then the K components. So I will be doing 2 minus lambda being equal to minus 4 plus 5 mu and so on. So this leads to 3 equations. We've got 2 minus lambda is equal to negative 4 plus 5 mu. We then have 8 plus 2 lambda being equal to minus 1 plus 4 mu. And then we've got 10 plus 3 lambda being equal to 2 plus 8 mu. I will pick 2 of the 3 equations, solve them simultaneously in lambda and mu. So from the first one, we get that 6 minus 5 mu is equal to lambda. From the second one, we get that 2 lambda is equal to minus 9 plus 4 mu. So I can substitute lambda is 6 minus 5 mu into this equation here, leading to 2 times 6 minus 5 mu is equal to negative 9 plus 4 mu. And therefore, we've got 12 minus 10 mu is equal to minus 9 plus 4 mu. So we've got 21 is 14 mu, which means that mu is 3 over 2. I will then proceed to find the value of lambda. So lambda is 6 minus 5 mu. This gives an answer of negative 3 over 2. And now I will go to the third equation and I will substitute the value of lambda and the value of mu we just found to see whether they agree with this third equation. So 10 plus 3 lambda is equal to 10 plus 3 times minus 3 over 2, which gives an answer of 11 over 2, whereas the 2 plus 8 mu is equal to 2 plus 8 times the 3 over 2, which is 14. Since 11 over 2 is not equal to 14, we conclude that the two lines do not meet, so L1 and L2 do not meet. So we have now ruled out the second possibility of the two lines intersecting at a point. So what we're missing here is an overall conclusion that since the two lines do not meet and are not parallel, then they must be skew. In question 10, we've got a spherical ball of ice of radius 12 centimeters placed in a bucket of water. Now, in a model of the situation, the ball remains spherical as it melts. T minutes after being placed in the bucket, the radius is r centimeters. The rate of decrease of the radius is inversely proportional to the square of the radius, and the radius of the ball is 6 centimeters after 15 minutes. Now we need to use the model and the information given to find an equation that links r with t. I will start with the fact that the rate of decrease of the radius is inversely proportional to the square of the radius. So dr dt is proportional to minus 1 over r squared. The negative sign is indicating that we're looking at the rate of decrease, and I will move from a proportionality to an equation by introducing the constant of proportionality, which I will call k. So dr dt is minus k over r squared, which means we're dealing with a differential equation which I will solve by separating the variables. So I will collecting the terms in r with dr on the left hand side and the terms in t with dt on the right hand side. So we're looking at r squared dr is equal to minus k dt, and I'm integrating. This leads to r cubed over 3 being equal to minus kt plus c. And then I can use the fact that originally the radius was 12, so when t is 0, r is 12, which means we're looking at 12 cubed over 3 being equal to 0 plus c, and therefore we conclude that c is equal to 576. Now we also know that when t is 15, the radius is down to 6 centimeters, so we're looking at 6 cubed over 3 being equal to minus 15k plus the c, which is 576. Now we're looking at 72 being equal to minus 15k plus 576, and therefore 15k is equal to 504. I divide both sides by 15 and I get that k is 168 over 5, and therefore we conclude that r cubed over 3 is equal to minus 168t over 5 plus 576. I can stop here because the question was asking for an equation linking r and t, so no particular form requested here, or I could proceed by multiplying throughout by 3 to leave r cubed on its own, or even taking the third root and leaving r on its own on the left hand side. In part B, we're asked to find the time taken for the ball of ice to melt completely. Now, if the ice melts completely, obviously the radius is down to 0. So I'll be substituting r is 0 into the equation we just obtained. So we're looking at 0 cubed over 3 being equal to minus 168t over 5 plus 576. So we're looking at 168t over 5 being equal to 576. I will divide both sides by 168 over 5, and we arrive at t being 17.1 minutes. I need to include the units here because this is a modeling question, so I need to include the units to claim both marks. In part C, we need to sketch a graph of r against t. Well, we know that dr dt is minus 168 over 5r squared. What we care about from this information is that dr dt is always negative, so we will be drawing something that keeps decreasing, and we know that after 17.1 minutes r will be 0, so it should be something like this with the 17.1 marked on the t-axis. In question 11, we've got a sketch of the closed curve with this equation, and we need to obtain an expression for dy dx. Now this is the question on implicit differentiation, so we differentiate from left to right. We apply all rules of differentiation as usual. If we happen to be differentiating a term in y, we put a dy dx term. So starting with x plus y raised to the power of 3, I will get the power down. I deduct 1 from the power times the derivative of the bracket, where the derivative of x plus y is 1 plus dy dx. Then we've got the derivative of 10y squared, which is 20y dy dx. And on the right hand side, the derivative of 108x is simply 108. So I will expand the brackets to get 3 brackets x plus y raised to the power of 2 plus 3 brackets x plus y squared dy dx plus 20y dy dx is equal to 108. Now remember, we're trying to make dy dx the subject here. So the first thing to do is move the 3x plus y squared over the right hand side, which leads to the right hand side being 108 minus 3 brackets x plus y squared. And out of the two terms remaining on the left hand side, we see there is a common factor of dy dx. So we're looking at dy dx, and then we've got brackets 3 brackets x plus y squared plus 20y, and this leads to dy dx being equal to 108 minus 3 brackets x plus y squared over the 3 brackets x plus y squared plus 20y as required. Now the curve is used to model the shape of a cycle track with both x and y measured in kilometers. Now points P and Q are representing points that are furthest the north and furthest south of the origin, and we need to determine how far point Q is south of O, giving our answer to the nearest 100 meters. So this is the diagram we've been provided. What we've been asked to find is essentially the y coordinate of the point Q. Let's recall that the y dx is the expression we just obtained from part A, and we know that at point P and Q we've got the y dx is 0, because if we were to draw the tangents we would see horizontal lines. So if I set the y dx to be 0, this simply means that the numerator should be 0. So we're looking at 108 minus 3 brackets x plus y squared is equal to 0. And therefore we've got 108 being equal to 3 brackets x plus y squared. I'll divide both sides by 3 to get 36 is equal to x plus y squared. And I'll take the square root of 36, leading to 6 being equal to x plus y. And therefore we can easily conclude that 6 minus y is equal to x. We will then proceed by recalling the equation of the curve, and we'll be substituting x being 6 minus y. So first of all, x plus y is simply 6. So we're looking at 6 cubed plus 10y squared being equal to 108 times 6 minus y. So we're looking at 216 plus 10y squared being equal to 648 minus 108y. I'll be collecting everything on the left hand side. We've got 10y squared plus 108y minus 432 is equal to 0. I'll be applying the quadratic formula to find the values for y. So y is going to be minus 108 plus minus the 108 squared minus 4 times 10 times minus 432, and all under square root, divided by 2 times 10. So if we plug this on the calculator, we get an answer of 3.1064 ... Or alternatively, we get that y is equal to minus 13.9064 ... Well, looking at the diagram here, P is the one with the positive y coordinate, so P has a y coordinate of 3.10 and Q has a coordinate of minus 13.9064. Remember, we're trying to find the distance of Q below the origin, so it's the y coordinate here. The units were kilometers, so the actual distance is 13.9064 ... kilometers, which we know that to the nearest 100 meters should be 13,900 meters.